Good afternoon, sir.
Good afternoon, sir.
Good afternoon, everybody.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. Good afternoon.
Good afternoon, sir.
Good afternoon. Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. So, have you had a class with Captain Takral today?
No, sir.
No, sir.
Okay. Tomorrow you'll be having a class with Captain Takral, I think, or I think next week onwards. So he will start your chart work. That's the plan of action, and so he will start that. Uh, how is navigation going? Are you able to understand?
Yes, sir.
You're able to understand what all is going on?
Yes, sir.
Okay. What topic is going on currently?
Nautical almanac.
Nautical almanac. Okay. So you all have a nautical almanac with you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So, so that means by next week the numericals will be starting, correct? Is that correct?
Yes, sir.
Yes, sir.
Okay. Are your difficulties getting sorted out?
Yes, sir.
Okay. Okay. Let me know if there is some topic where you are not able to understand. Okay. सब चुप हो गए, बोल नहीं रहे कुछ? Okay, चलो ठीक है. All right, let's go back to our topic that we were doing yesterday. Moment of statical stability or transverse statical stability. Any doubts from exercise 9 or any of the previous questions?
तो बाकी सब चीजें समझ में आ गई थी. कोई ट्रांसवर्स मेटा सेंटर बता दीजिएगा प्लीज वापस से.
Transverse meta center. Okay.
ये कैसे डिसाइड?
Okay. So basically, transverse meta center. Actually, okay, I'll come to it today.
सर बोर्ड पे बता दीजिएगा.
Yeah, okay. बोर्ड पे समझाता हूँ. All right. Okay. So basically, what is there is, if this is a cross section of a vessel, a transverse cross section. Okay. This is a transverse cross section. This is the keel. And she is floating at this draft. This is the water line. Now, the center of buoyancy will be somewhere here, and the center of gravity will be somewhere here. Okay. So, through the the G, the W will be acting downward like this. This is through the G. And through the B, W will be acting upward like this, the force of buoyancy. And therefore, the vessel is in stable equilibrium. Now, if I start to incline this to the starboard, okay, I'm inclining it to the starboard. So अब इसी vessel को मैं incline कर रहा हूँ, right? Now when I'm inclining it like this, so ये मेरा जा रहा है ऐसे, this is the keel. जैसे ही मैंने, अच्छा जी तो वहीं का वहीं है, क्योंकि मैंने कोई वेट को तो शिफ्ट किया नहीं है, लेकिन मेरी अंडर वाटर वॉल्यूम स्टारबोर्ड साइड पे ज्यादा हो गई है. तो since my underwater volume on the starboard side is more, therefore my B1 will shift in a direction like this, somewhere over here, and it is through this B1 that the force of buoyancy will now act vertically upward. Do you all agree to this? Yes or no?
Yes, sir.
Okay. So if my B1 will shift in a direction like this, अब क्या सिचुएशन होगी कि मेरा W थ्रू G तो ऐसे एक्ट कर रहा है, and now my force of buoyancy equal to W is going to act vertically up through Bravo 1, and so therefore this will be my vertical, which will go up like this. जहां पे ये ओरिजिनल वर्टिकल लाइन को मीट करेगा, उस पॉइंट को हम एक नाम दे रहे हैं M, मेटा सेंटर. This is my theta. तो इसकी इंपॉर्टेंस क्या है? सो बेसिकली इसकी इंपॉर्टेंस ये है, या हाउ टू डिफाइन मेटा सेंटर. It is an imaginary point in space where the vertical through the center of buoyancy in the upright condition and through the center of buoyancy in the heeled condition, they meet. That imaginary point is known as meta center. Since the axis in question is a transverse axis, or the side which we are talking about is transverse side, therefore the M has got a small subscript T attached to it, which is called as transverse meta center. This is called as MT. Now, बेसिकली इसका क्या मतलब है? इसका मतलब ये है कि अगर ये एक धागा होता और यहाँ पे एक पॉइंट होता, ये धागे से ये शिप सस्पेंडेड है ऐसे, तो अगर मैं इस जहाज को ऐसे पेंडुलम की तरह स्विंग करता, तो ये ऐसे स्विंग करता अबाउट दिस फिक्स्ड पॉइंट MT एंड अटैच टू अ धागा. एक्चुअल में कोई धागा नहीं है, बट वो मैं खाली एक्सप्लेन करने के लिए बता रहा हूँ कि एक धागा है. तो देयरफॉर ये KMT बन जाता है. और अच्छा, पहले तो यहाँ तक पहले कोई डाउट है? एनी डाउट अप टिल नाउ?
नो सर।
ओके, अब यहाँ से G से मैं ये एक परपेंडिकुलर ड्रॉप करता हूँ, ये परपेंडिकुलर है टू दिस लाइन, टू दिस B1 empty को ये परपेंडिकुलर हिट किया, तो ये पॉइंट Z कहलाएगा, and therefore GZ is called as the writing lever, the lever which will cause the vessel to become upright. अगर मैं इस जहाज को और इंक्लाइन कर दूं, पहले मैंने 10 डिग्री किया था, अब मैं 20 डिग्री कर दूं, अगर मैं 20 डिग्री करूंगा तो B2 और बाहर चला जाएगा, राइटिंग लीवर और बढ़ जाएगा, जो नया GZ होगा वो और बढ़ जाएगा। दैट मीन्स मैं जैसे जैसे इंक्लाइन करता जाऊंगा राइटिंग लीवर बढ़ता जाएगा, और ये बढ़ता है अप टू रफली अराउंड 40 डिग्रीज, 40-45 डिग्रीज तक बढ़ता है राइटिंग लीवर। एनी डाउट अप टिल नाउ?
नहीं सर।
सो नाउ ये जो मेरा GM है, GMT जिसको मैं कह रहा हूं जी, ये T इज साइलेंट, ओके, T हम साइलेंट रखते हैं, तो उसको हम GM बोलते हैं, GM इज GMT, ये ट्रांसवर्स मेटा सेंटर। तो बेसिकली ये जो when kg is less than km, then gm is said to be positive. जब भी g m से नीचे होगा gm को पॉजिटिव कहेंगे, and vessel is said to be in stable equilibrium. Vessel is said to be in stable equilibrium. अब तो स्टेबल इक्विलिब्रियम का मतलब है कि अगर ये जहाज को मैं इंक्लाइन करता हूं तो ये जहाज वापस आ जाएगा। दिस इज स्टेबल इक्विलिब्रियम। शी विल कम बैक टू हर ओरिजिनल सेल्फ। जब मैं इसको पुश करूंगा ये वापस आ जाएगा। दैट इज द peculiarity of the stable equilibrium or the indication of stable equilibrium. Now, अगर मैं नीचे से अपने लिक्विड्स कंज्यूम करता रहूं, सपोजिंग मेरे बंकर टैंक्स नीचे हैं, फ्रेश वाटर टैंक नीचे है, तो सपोजिंग ये मेरे बंकर टैंक्स हैं या फ्रेश वाटर टैंक्स हैं, एंड मैं इसमें से अपने लिक्विड्स कंज्यूम करता रहा, तो अगर मैं यहां से कंज्यूम कर रहा हूं लिक्विड्स, विच इज व्हाट हैपेंस एट सी, तो मेरा जी कहां, किस डायरेक्शन में जाएगा?
सर अपवर्ड्स।
सो माय जी विल
ऊपर की तरफ सर।
करेक्ट। सो व्हेन आई एम कंज्यूमिंग एट सी, what will happen? Two things will happen. One, so due to consumption of liquids at sea, what all will happen? Number one, my displacement will reduce. Agreed? My W will reduce. If my W will reduce, my Km will reduce. That means my M will start coming down, because Km is directly proportional to displacement. If displacement increases, Km increases. So Km will reduce. Simultaneously, Kg will increase. Do you agree?
Yes, sir.
Okay. A point in time will come when the G and the M will coincide. So when Kg will be equal to Km, that means that they coincide. What will be the value of Gm?
Zero.
Zero. So Gm is 0. This is said to be neutral equilibrium. This is said to be neutral equilibrium. That means ये G और वो M नीचे आ गए. Gm is 0, neutral equilibrium. There will be no writing lever. Writing lever will be 0. Gz will be 0. At this stage. I keep consuming my liquids more and more. So what will happen? My G will overshoot M. Once Kg will increase beyond Km. So what will happen? Kg is greater than Km. Gm
सर
is
एक
said to.
बारी
हाँ जी बोलिए.
एक बारी इसका डायग्राम में बता दीजिएगा कैसे रहेगा kg ग्रेटर देन km.
Okay. So okay. So मैंने G को ऊपर लेता जा रहा हूं. So let us say G यहां पे आ गया. This is G. This is my original B. Right. Now, क्योंकि मैं उसको कंज्यूम करता रहा, तो अब एज ए रिजल्ट मेरा B1 यहां पे आ गया. एंड इसके थ्रू जो वर्टिकल जाएगा वो ऐसे जा रहा है. So as a result, this becomes my M. Now my writing lever will be on this side. This is GZ. This is G. Writing lever has come onto this side. So this situation is Gm is negative. G has gone more than M. G is more than M. Gm is negative. Vessel is in unstable equilibrium. Vessel will have a negative writing lever. In stable equilibrium, GZ was positive writing lever. Now vessel will have a negative writing lever. That means this vessel, which will be like in this position, will tend to go more away from upright negative, towards upright positive writing lever. So this will go away from upright more. That is called as unstable equilibrium. ये समझ में आया?
Yes, sir.
Yes, sir.
हाँ जी. Any doubts now? So all this is happening. Why? Because I am consuming liquids at sea. This is all happening because of that. W is reducing, Km is reducing, Kg is increasing, and therefore the G and the M will coincide, and then the G will overshoot M. So the vessel sailed out from port in a stable equilibrium, at sea went to a neutral equilibrium, and then went to an unstable equilibrium at sea because she kept on consuming.
तो सर इसका एंगल ऑफ हील से रिलेशन रहेगा कि नहीं रहेगा, मतलब अगर अनस्टेबल कंडीशन में
एंगल ऑफ हील से रहेगा ना, बिकॉज अब तो और ज्यादा एंगल ऑफ हील पे जाएगा जहाज. शिप विल गो टू अ लार्जर एंगल ऑफ हील. पहले तो छोटा सा एंगल ऑफ हील था, लेकिन अब ये लार्जर एंगल ऑफ हील पे जाएगा. शिप इज इन अनस्टेबल इक्विलिब्रियम. ओके, नाउ जैसे ही ये जहाज स्लेट से स्टार्बोर्ड जाना शुरू हुआ, पहले 5 पे गया, फिर 10 पे गया, अब 15 पे गया. तो जब ये 5, 10, 15 पे जा रहा है और फिर 20 पे जाएगा, तो व्हाट इज हैपनिंग टू दी एम? The m will start to rise. The m will start to rise. G will remain same. M will start to rise. And at some point in time, the G and the M will coincide. At some point in time, the G and the M will coincide. Once the G and the M coincides, Gm will be 0 again. So Kg will be equal to Km. Gm will be 0 again. Vessel will again be in the neutral equilibrium for the second time. Vessel will be in the neutral equilibrium for the second time. This angle of heel at which vessel is in neutral equilibrium for the second time is called as angle of Lowell. So what is angle of Lowell? Angle of Lowell is that angle of heel at which the GM becomes 0 again. That is how you define angle of log. It is that angle of heel at which the GM becomes 0 again. That is called as angle of log. How do you show it? You show it like this. The original M was here. The M began to rise as I kept on increasing the heel. So therefore, M went to M1, coincided with the G. GM1 has become 0. It has become 0 again. It was 0 initially also, before it went to angle of log. Now it has gone to this is so this
शिप पे तो कंज्यूम कर रहे होंगे ना, तो केजी बढ़ता ही रहेगा.
तो इसीलिए हमें कैलकुलेशन करनी पड़ती है इस तरीके से कि जब मैं डिपार्चर पोर्ट सेल आउट करूं, मैं अपने लिक्विड्स ऐसे रखूं कि माय लिक्विड्स आर इन माय टॉप टैंक्स. मेरे लिक्विड्स जो हैं, जो मैं कंज्यूम करूंगा, मेरे बंकर्स, मेरा फ्रेश वाटर, वो टॉप साइड टैंक्स पे होना चाहिए, ताकि मैं ऊपर से कंज्यूम करूं तो मेरा जो जी रिजल्टेंट एट सी शिफ्ट होगा, वो किस डायरेक्शन में जाएगा?
सर
नीचे जाएगा, वो डाउनवर्ड जाएगा. सो इवन दो मेरी डिस्प्लेसमेंट कम हो रही है, मेरा केएम कम हो रहा है, लेकिन मेरा जी भी नीचे जा रहा है. And as a result, my GM will remain positive. This is what I have to make sure. So I should not sail out with this. Even if I do sail out with this, I will consume only from top tanks. I will not consume from bottom tanks. This is what the mate makes sure. Is that okay?
Okay.
Haji, any doubts on angle of Lowell? Any doubts on angle of Lowell?
एंगल ऑफ लॉल तभी फॉर्म हो सकता है जब अपना स्टेबल इक्विलिब्रियम में.
नहीं, तब नहीं हो सकता. अगर स्टेबल इक्विलिब्रियम में है तो मेरा जहाज, आई हैव गॉट अ पॉजिटिव राइटिंग लीवर, मैंने जैसे ही हील किया मेरा जहाज सीधा आ जाएगा वापस, क्योंकि जीजेड मेरा पॉजिटिव है. दिस इज अ पॉजिटिव जीजेड, दिस इज अ नेगेटिव जीजेड. पॉजिटिव जीजेड, नेगेटिव जीजेड.
सर पर जैसे जैसे हील होएगा मेटा सेंटर, ट्रांसवर्स मेटा सेंटर भी तो नीचे आता जाएगा अपना, अगर ज्यादा हील हो गया तो.
नहीं, बेसिकली जैसे मैं हील करता हूं तो जो ट्रांसवर्स मेटा सेंटर है वो शुरू में नीचे आता है, फिर ऊपर जाना शुरू हो जाता है. सो 12 डिग्री तक वो ऑलमोस्ट कांस्टेंट रहता है, 15 डिग्री तक. तो इसलिए हमने कहा कि केएम इज कांस्टेंट. उसके बाद फिर वो बढ़ना शुरू हो जाता है 15 डिग्री के बाद. M starts to rise. So that is why. ये क्लियर है, ये सारा जो भी हमने जितना भी डिस्कस किया. So once my vessel is at angle of lol at sea, so now my vessel is at angle of lol. I need to take some corrective actions and bring her back upright. Otherwise, I'm in a dangerous situation. Why am I in a dangerous situation? Because I am still consuming. So मैं और consume करूँगा नीचे से अपने liquids. The G will again go up. GM will again become negative. Negative writing lever. Again the vessel will start to heal more. अब पहले 20 डिग्री था, अब 25 हो जाएगा. फिर से जहाज आके रुक जाएगा, फिर GM 0 हो जाएगा. Again, triple, third time. This is the new angle of lol. That means each time my vessel will keep going to a new angle of lol. So पहले 20 था, फिर 25 हुआ, फिर 30 हो जाएगा. And this process capsizing moment. ये healing moment capsizing moment बन जाएगा. And my जहाज will capsize. That is how a vessel sinks. So our action has to be to bring her back to upright. Then we do a set of actions that we'll discuss separately. That is not in your syllabus. What action to take? वो mates में आ जाता है. But essentially, this is the sequence of sinking a ship. Angle of lol is one step before the sinking. So there are some ships which inherently go to an angle of lol. वो उनकी inherent capability है जहाजों की. उनमें से सबसे ऊपर वाले नंबर पे आता है timber carrier, log carrier. They are inherent. They'll go to an angle of lol. क्यों? क्योंकि डेक पे कार्गो लोड करते हैं, लॉग्स डेक पे लोड करते हैं. तो क्या होता है, इन जहाजों का जीएम बड़ा कम होता है. दे सेल आउट विद वेरी लेस जीएम, much less than our tankers and bulk carriers, because they load deck cargo also. So GM बहुत कम हो जाता है because kg ऊपर होता है. At sea they keep consuming liquids नीचे से, तो GM पहले 0 बनता है, फिर नेगेटिव बन जाता है, and therefore these ships go to an angle of flow at sea. So whenever these ships are on long voyages, log carriers, they have a good tendency. So mate has to be very very careful and cautious on these ships कि इसको angle of lol पे जाने नहीं देना. So calculations have to be very very strict. Then another ships which go to an angle of lol are container carriers. Now you tell me how container carriers can go to an angle of lol. Containers. How do container ships go to an angle of lol?
sir, they also load
सेंटर ऑफ ग्रेविटी
containers.
ऊपर रहता है उसका.
Hmm?
So they also load containers on very high tiers. That's why kg increases and GM reduces.
But something more. I need something better than this. I need a better answer. That is one easy one you've given me. That is a cadet level answer. I need something from a mate, second mate level. Container guys, come on. All those who have been on container ships. What is the problem with container ships? Container vessels. No? There are no container guys in the class? Come on, container guys. All those who have been on container ships. So containers, you can have what is called as FCL, full container load, right? Or you can have LCL, less container load. That means partial containers loaded. Or you can have empties. So supposing I have FCLs, full container load, which is carried on the top deck, and I have empties down below. What will happen?
Sir, G will shift to the top side.
Correct. And this is all being done why? Because of port rotation. Because it has to meet the port rotation requirement. So empties go under deck, and the full container load, a heavier cargo, goes on top. The G is on top. Now these ships are tender. GM is very low. And at sea, they can go to an angle of flow. That's how container ships are very vulnerable for going to an angle of flow. So these ships will have what is called as anti-heeling tanks. Anti-heeling tanks होते हैं जहाजों के जो इस चीज को संभालते हैं. अगर ये जहाज स्टारबोर्ड हील करता है तो एंटी हीलिंग टैंक पोर्ट साइड लेता है बैलेस्ट एंड देयरफॉर उसको करेक्ट करता है इमीडिएटली और इमीडिएटली करता है. So that is how containers ships can go to an angle of flow. Another ships which go to an angle of flow are passenger ships. Tell me how passenger ships go to an angle of flow. Anji, passenger ships. What is the cargo?
सर उनका ड्राफ्ट कम रहता है.
नहीं. What is the cargo on passenger ships?
Passengers itself.
Passenger. So what will happen on these ships? What if all the passengers go on the top sun deck to do sunbathing? सबके सब ऊपर चले गए. AG has risen. Yes or no?
Yes, sir.
Yes. Yes, sir.
So KG बढ़ गई. GM कम हो गया. Vessel will go to an angle of roll. So passenger ships are very prone. सारे के सारे पैसेंजर अगर ऊपर पहुंच गए. So how do these ships prevent? They have something called as access control. Not every passenger can go on top deck. They control the access. So a passenger can only go one deck up. That's it. From bottom decks. Top deck guys can go as much below. But bottom deck guys can only go one deck up. So they control it. So the access, the card which you have, you will not be allowed to go beyond. That's how they control it. Similarly, there's another problem in passenger ships. Whenever passenger ships have to approach a port, सारे के सारे पैसेंजर जेटी साइड पे आ जाएंगे. Correct or not?
Yes, sir.
So the ship will immediately take a list. कार्गो शिफ्ट हो गया, सारा का सारा आ गया जेटी साइड पे कार्गो. How do you prevent it? Again, access control. Port to starboard movement is also controlled. जो पोर्ट पे है वो पोर्ट पे ही रहेगा, जो स्टारबोर्ड पे है वो स्टारबोर्ड पे ही रहेगा. So they control the access. And therefore, these passenger ships, whenever they approach the jetty, they will always approach perpendicular to it. They will never approach sideways like we do. They will approach perpendicular, ताकि कोई side ही ना हो. So passenger ships approach is always perpendicular to the jetty. And then last minute they'll swing using the bow thrusters and whatever they have. So this is your passenger ship's key problem. Then some tankers also go to an angle of flow. Suezmax tankers. So some of these tankers which were built during the 90s, Suezmax tankers, double hull. This is the cargo oil tank. This is the water ballast tank. So when the vessel came to load at the jetty, deballasting was on, right? So therefore, when the cargo is loaded partially in the cargo oil tank and the water ballast comes below this level while deballasting, the free surface increases maximum, LB cube, maximum breadth. This caused the free surface to increase, maximum free surface. And so therefore, these vessels also went to an angle of flow. This was called as U-tube effect. And this was prevalent only on these Suezmax tankers. 1,65,000 tankers. It was found that the centerline bulkhead was not completely done while making these ships. So in the next dry dock, this was completed and made it into like this, joined like this. So the U-tube was converted into a J-tube. This was called as J-tube. And that is how this free surface effect was reduced. And that is how these Suezmax tankers then, so these vessels, while deballasting, they have to go through a sequence of loading and deballasting. If I'm loading in number 4 tank, then I will not deballast number 4. I will deballast number 2, some other tank. So they follow a proper sequence. So very experienced mates are put on these ships to handle it. So these are your Suezmax tankers which go to an angle of flow. So this is your bit of information about unstable equilibrium, angle of Lowell, and it has to be done very carefully. If your vessel is at angle of Lowell and is at sea, you must stop the vessel immediately, take shelter, and do the corrective action. Bring the vessel upright, then only move. Otherwise, capsizing moment will come anytime. So one has to be very, very careful. ठीक है? Is that okay? All right. I have finished chapter 10 and chapter 11, both. You can do a revision from the book. There are no questions, no numericals. Chapter 10, chapter 11. Please just go through the theory part, whatever I've discussed in class. Just revise it out. इस पे theory question आ जाते हैं. What is a stable equilibrium, unstable equilibrium, neutral equilibrium, angle of Lowell, and the theory of it. So whatever I have explained to you, that will be the one. And types of ships, which I told you, that was extra information. That was not from exam point of view. That was just from knowledge point of view. ठीक है? Is that okay?
Yes, sir.
Yes, sir.
Okay. चलो. ठीक है? See you then. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Bye. Bye.